Hi, so we've got an experiment with the Zoom B1XFour. Bear with me because I'm a bit colorblind. So here we see we've got the top jumper pin of the endless encoder of the Zoom, and that's going into yellow, and the bottom one's going into red. And at the moment, I'm putting that into a mega, and I'm using 3 for the red and 2 for the yellow, just to check. And then we're going into a piece of code I found on the internet, so I'll give credit in a minute. So the code, sorry, is here. And actually, let me just move it up so we can see the dude where I got the information from. So it was a couple of things. It was the Arduino reference itself, but this dinpar.com technology encoder basics quadrature encoder is the one to look at. Oh, there we are. When we look at the website, we see that the basic of quadrature is that it's just an out of phase signal. So what it looks like Zoom are doing in standard way with these 3-pin encoders is the middle one is some sort of reference, and it generates zero reference, and it generates a signal on the top and the bottom pin. So now when we look at the encoder itself, this is the code. So what we're saying is, okay, pin A is low, high, high, low, and then pin B is just to the out of phase, yeah? So you just move it like that and swap it round to the edge, okay? And then the other one, I've copied it down the other way. Yeah, right pin A is left pin B, and right pin B is left pin A. Now, I don't know if that works, but it seems to be okay. And I'll get this, I'll think about it. I'm just doing a basic video of what's going on, yeah? So what we're doing is we're going around 4 at a time, and we're sending pin AI. So what we'll be sending is low to A and low to B, high to A, low to B, high, high, low, high, and that should bump the encoder one way. And then we got another one here where we send the right pin A, right pin B. So we send low, 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 high, high, low, high, low. So let me just pause this. We'll put this in and see what it does. Okay, this is the Zoom booting up. And now it should start to push. There's a 45 minus 40. So that's getting bigger by 1. Yeah, that's turning it, and now it's going back the other way. Down 4 and up 4. So let's try and put this a little bit more in the mid-range, if I could. I'm going to do it by hand. I'm going to hold the reset down. I'm going to move the thing back. Okay, so what I've done is I've held the reset down and I put it to 0. So I assert it should go like, I don't know, plus minus 4, something like that. Let's let go. So the Arduino boots up, and we're going 0, minus 1, minus 2, minus 3, minus 2, minus 3, 0. Yeah, we're cycling at 1 to 0. So it's just going back and forth a little bit, yeah. Boom, boom. And when we look on the code, let me just put this onto view. Hang on. So we're sending this cycle, I guess I should say left or right and get it in my own mind correct, yeah. But the basic thing is that the code here is now able to control the endless encoders, albeit of course we'd expect it to work its own way, you know, by sending the pulse ourselves under control. So if something comes in, maybe we would tap a button on a foot switch. A digital output, so we're writing, not reading. So you need 8 digital outputs, which would be, is it? No, it's only 4 switches. No, yeah, it would be 8 switches, wouldn't it be? Left, right. So yeah, there'd be. I got to think this through. There'd be 8 extra parameters. I've already got 12 switches. 20 switches might be a bit much. Maybe I'll make a separate box for that. But anyway, the point is that I'll work this out myself. I'm very colorblind. I'm a good mathematician, but I'll have to work out how I've set this up, compare the code so that I say if you put it there, this is like left and that's right. Because it might be, see, if it's that way round, that's left and right. If it's that way around, then that's left and right, yeah. And then of course when you go to the other side of the board, it inverts anyway. So I just got to work this out, but it's quite exciting. Yeah, we can use an Arduino to send pulses as if we were doing it ourselves, yeah. So it's digital write from the Arduino and that's enough to send it. So I feel a bored coming along. Anyway, thank you for your time, and bye-bye.